Okay, today we are looking at ratio and rate problems. We are in lesson 1.7 on page 71. An arcade sells game tokens individually or in packages. They are having a sale on token packages as shown below. So one package would be $5, two packages would be $10, three packages would be $15. How many token packages can you buy with $20? And then what about 25? So we can continue this pattern by extending our table to include 4 and 5. Okay, and we can see that as the number of packages increases by 1, the price increases by $5. So $5 per package. So 5, 10, 15, 20, and then 25 because we're increasing at a consistent rate. Want to zoom in on that table. So 1, 2, 3, 4, 5, our X values increase by 1, and our Y values, our price increases by 5. 5, 10, 15, 20, 25. How many token packages can you buy with $20? 4 token packages. And how many token packages can you buy with $25? 5 token packages. Okay, and then we needed to explain that. So as you add one additional token packet, the price increases by $5. Okay, and then the next question asks, what is the unit price? The unit price is $5 per package. $5 per package. How much would it cost to buy 6 token packages? So 6 token packages times $5 per package would be $30. Number 4, the arcade sells individual tokens for 25 cents each. If a token package contains 25 tokens, how much would you save by buying a package of 25 tokens instead of 25 individual tokens? Okay, so if we had 25 individual tokens at 25 cents each, we would say 25 tokens times 25 cents, and then we'll go ahead and multiply. So 25 individual tokens would cost $6.25 because 25 times 0.25 was 6.25. So $6.25. And they asked us how much would you save? And then that is a way of saying what's the difference between the higher price and the package price. So we know that each individual package of tokens was $5. So we would subtract the $5, then $6.25 minus $5 is $1.25. So we save $1.25 by buying a package instead of individual tokens. So you would save $1.25 by buying the package. Okay, and that was page 71. The learning target for this lesson that we are doing today is to use ratio and rate reasoning to solve real world problems and mathematical problems. That's our learning target for today. Okay, and then we'll turn the page to page 72. Okay, so now we're on page 72. Solving ratio problems. You can use bar diagrams or equations with equivalent ratios to solve ratio and rate problems. Example 1, Heritage Middle School has 150 students. 2 out of 3 students. So when I see that, I'm going to write the ratio 2 out of 3 or the fraction 2 out of 3. We could also write it this way. Okay, so 2 out of 3 or 2 over 3. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So we know from the problem that there are 150 students in Heritage Middle School. So if we draw a bar diagram for our 150 students, here is 0, 150. And then we break that 150 up into 3 groups. There would be 50 in each group. So 50, 100, 150. So if we count by 50s, if we can zoom in a little more on that. So this is 0, 50, 100, 150. I'm just going to write that a little bigger. So we can split that up into a tape diagram of 50, 50, and 50. Okay, so if we know that, so now we have, and the reason we chose 50 was because 50 goes into 150 3 times, and we knew we were looking at 2 out of every 3 students. So then we can take our 150 and we can break it up into 3 groups, 50, 50, and 50. And then 2 out of those 3 would be this one and this one. So 100 students prefer gel toothpaste. At Heritage Middle School. Okay, so that's one method, is that visual diagram. It's called a tape diagram. Okay, we can also set up and solve a proportion or equivalent ratios. So if we look at method 2, same problem, let's use a different method. So our next method with that same exact problem, we will use equivalent ratios. So we can say 2 out of 3 students prefer gel. So how many, or blank, which we will eventually with algebra turn that into an X. So blank out of 150. Okay, so we look for proportional reasoning. We see that going from, we look for pattern from 3 to 150, and we see that's times 50. And so whatever we do to the denominator, we also need to do to the numerator times 50. So 2 times 50, this was times 50 that we did in the denominator. So we need to do the same thing in the numerator times 50. So 2 times 50 would give us that 100. So 100 students would prefer gel toothpaste. Moving on to number 2. All right, let's get that straightened out. The ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. So Lucas to sister is 3 to 4. So the sister sends more text messages than Lucas does. Lucas sent 18 text messages. So I'm going to go make an equivalent ratio. And Lucas, his information is all in the numerator. His information is all in the numerator. So we'll put the 18 right here. And then we look for a ratio here. So from 3 to 18, we multiply by 6. So when Lucas sends 18 text messages, how many would we expect his sister to send? So whatever we do to our numerator, times 6, we also do to our denominator, times 6. And 4 times 6 is 24. So his sister would send 24 text messages. Okay, and I did method 2 first, which actually is, I'm looking ahead, sorry, it's at the top of page 73, so we jumped ahead. I did method 2 first. That's my favorite method. Okay, we'll do the method 1, the bar diagram, second. So I just reversed those orders as to compared to how it is in your textbook. Okay, so let's go ahead and look at method 1, which is already done here for us. So we can see method 1 using a bar diagram. So ignore this writing here. That was actually method 2. Draw the bar diagram. So we draw the bar diagram, okay? And then determine how many text messages are in each section. So the sister has, we don't know yet at this point, so it's already solved for us, but Lucas sent 18. So we can draw his 18. 6 and 6 and 6 would give us 18. There's 3 parts. We take that 18, we divided it by 3 to get the 6, and that's how we know to put a 6 in each of those boxes. And then we know that the ratio is 3 to 4. So if he has 3 boxes of 6, she needs to have 4 boxes of 6, because we know in the problem the ratio is 3 to 4. So he has 3 times 6, 18 messages. She has 4 times 6, 24. So 4 times 6 is 24. Okay, so 24 text messages sent by his sister. "24 text messages sent by his sister." Okay, turning to page 73. In a survey, 4 out of 5 people preferred creamy over chunky peanut butter. So creamy over total. Okay, so creamy peanut butter, 4 out of every 5 people prefer the creamy peanut butter. There are 120 people shopping at the grocery store. Use the survey to predict how many people in the store would probably prefer creamy peanut butter. So we'll make a prediction. There are 120 people total. So we want to see how many times 5 can go into 120. Well, I know 5 can go to 100 into 120 times. It can go into 24 times. So this is times 24. And so then I need to increase that 4 by that same factor. 4 times 24 would be 96. And we can do that with mental math, because 4 times 25 is 100. 4 times 24 would just be 4 less, or 96. Okay, so 96 people would prefer creamy. A survey found that 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. So 12 out of 15 people prefer eating at a restaurant and over cooking at home. If 400 people selected eating at a restaurant, so remember 12 is how many people said they prefer eating at a restaurant. So that corresponds with 400. So since 12 is in the numerator, 400 also needs to be in the numerator. So if we wanted to label these to help us to remember, that's always a great idea. Restaurant over total people. Okay, 4 out of every 5 people, or excuse me, 12 out of every 15 people prefer eating in a restaurant. Okay, 3 out of every 15 people prefer eating at home. Okay, so then we're going to set up our proportion or equivalent ratios. And we want to know how many times 12 goes into 400. This is not something, so 12 times what goes into 400. This is not something that most of us can do in our heads. So we're going to work backwards. And so if I want to see what 12 needs to be multiplied by to get to 400, I can start off with 400 and then divide it by 12. So 400 divided by 12 is 33 1/3, so 33.3 repeating. So to get from 12 to 400, and I'm kind of don't have a lot of space, I'm going to write it up here. So it's times 33.3 repeating. So then I need to follow that same proportion here in the denominator, because whatever I do to the numerator, I do to the denominator. So that times 33.3 repeating. Okay, and again, how did I get that 33.3 repeating? I did 400 divided by 12. I worked backwards. Now I know what that factor is. I do this multiply 15 by that same number. So I'm just going to leave it in my calculator because I already have the 33.3 repeating, and I'll multiply it by 15. So times 15. So this is 33.3 repeating times 15, and we get 500. 500 people took the survey. Solving rate problems, you can use double number lines or equations to solve rate problems. We're going to go ahead to example 3. The Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? So we'll use our proportion method first. So 105 miles to 4 miles to gallons. So 105 miles used 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? So blank over 6, so 6 gallons of gas. Now 4 doesn't go into 6 easily. Okay, so I have 2 choices. I can scale this down, divide by 2. I'm going to show you that method in just a second, but let's go ahead and look at what do I need to multiply 4 by to get to 6. Many of you can probably do that in your head. That's times 1.5. So 4 times 1.5 is 6, and you can see that by checking on your calculator. If you weren't able to do that in your head, that's okay. You can get it by working backwards. I'm going to zoom in a little bit. So you could do 6 divided by 4, 6 divided by 4, and that gives you the 1.5. So that way you know to get from 4 to 6, you had to multiply by 1.5. And then whatever you do to the denominator, you also need to do to the numerator times 1.5. So now we can take that 105 and multiply by 1.5. And this is actually on your test, it's non-calculator. So you would do this longhand, but just for sake of the notes not being super long, we're just going to use the calculator for that. So 157.5 miles. Okay. And then let's go ahead to example C. At the bottom, there are 810. We're not going to do the double number lines today. We'll come back to that when we look at the homework. We'll do some examples of that together. Example C, there are 810 calories in 3 scoops of ice cream. So calories per scoop. And we know that there are 810 calories in 3 scoops. So calories per scoop. And this division line is our per, or the fraction line is our per, and that means divide in math. So 810 calories per 3 scoops. How many calories are there in 7 scoops of ice cream? So I'm actually going to scale this down. I want to know how many calories per scoop. So I'm going to do a middle step here. I'm going to do 1. I want to know how many calories are in 1 scoop. So how did I get from 3 to 1? I divided by 3. So what do I need to do to my 810? I also need to divide by 3. 810 divided by 3 is 270. So 270 calories per 1 scoop of ice cream. And then they're asking us how many calories in 7 scoops. So now I'll scale that up because 3 doesn't go right into 7. I still could figure this out, but I know there are 270 calories per 1 scoop. So now I can scale that up to 7 to see 7 scoops is a lot of ice cream. I hope you're not eating 7 scoops of ice cream. So to get from 1 to 7, we multiply by 7. So to get from 270, which is how many calories are in 1 scoop, to how many calories in 7 scoops, we'll go ahead and multiply 270 times, get that on the screen, times 7, 1,890. Okay, so 1,890 calories in 7 scoops of ice cream. Jeremy, we're on page 74 now. Jeremy drove his motorcycle 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? So we want to know how many miles per hour, and then we can scale that up to 5 hours. So we see that it took 3 hours to go 120 miles. So I want to know per 1 hour, I divide by 3. So I also need to take the 120 miles and divide that by 3. That'd be 40. So Jeremy is driving at 40 miles per hour on his motorcycle. Okay, and so then once we know that 40 miles per hour, we can just multiply that by 5 hours. So 40 miles per hour. So each hour you drive, or Jeremy drives 40 miles. And if we multiply that by 5, because he's driving for 5 hours, that would be 200 miles. So Jeremy can drive 200 miles in 5 hours, driving at a rate of 40 miles per hour. Then moving on to letter D. While resting, a human takes in about 5 liters of air in 30 seconds. So we're going to write that as a rate, 5 liters per 30 seconds. So this is liters over seconds. At this rate, how many liters of air does he take in during 150 seconds? So we'll make that, so seconds are in the denominator. So we'll put the 150 in the denominator. And then we ask ourselves, what do I need to do to the 30 to get to 150? That's times 5. So my denominator got multiplied by 5. That means my numerator also needs to get multiplied by 5. So 5 times 5 is 25. And my units in the numerator are liters. So 25 liters are breathed in during 150 seconds at rest. Okay, and that was lesson 1.7, solving ratio and rate problems.